Our methodology consists of laboratory analysis as well as subsurface analysis. In laboratory analysis, to find the rank of coal, we performed proximate analysis to find moisture content, volatile matter, ash content, and fixed carbon. And to find the internal structure, we performed SEM analysis to identify cleat patterns and cleat types. To find the gas adsorption capacity, we performed TOC and mesoral analysis to find organic matter content and mesoral types. Beside laboratory analysis, we have performed some subsurface analysis to find the coal seam and lateral continuity. For that purpose, we performed well log analysis and seismic interpretation. Both the laboratory analysis and subsurface analysis can lead to find the potential of methane gas in Patala formation coal seam. For the proximate analysis, we prepared a sample of 10 gram passing through sieve number 60, and from Quaid-e-Azam campus Lahore, we performed this test to find the rank of the coal. For scanning electron microscope, we prepared a solid sample, and from University of Azad Jammu and Kashmir, Muzaffarabad, to find internal structure. And for the total organic content and vitrinite reflectance, we prepared a sample of 1 millimeter and sent this sample to Hydrocarbon Institute of Pakistan to find organic matter and vitrinite reflectance value and mesoral types. During our feed, we visited different coal mines like PCP mines, Dundot coal mines, and Gamrala coal mines. Here is the representative samples of our research. In the subsurface analysis, we used Balkasar Oxy 01 well and Balkasar 01A well to find the coal seam in the subsurface and gas effect in the coal seam. Further, we used some seismic lines to find the lateral continuity of the coal seam and depth of the coal seam. In PCP mines, the coal depth ranges from 450 to 475 meter with a thickness of 3.1 to 3.5 meter. The Dundot coal mines coal is at the depth of 400 to 425 meters with a thickness of 2 to 2.5. The Gamrala coal mines coal is located at the depth of 340 to 360 meters with a thickness of 2.3 to 2.7 meters. In our analyzed samples, we have total moisture content ranges from 3.95 to 7.53%. The volatile matter ranges from 22.43 to 46.03%. The ash content ranges from 20.44 to 55.87. The fixed carbon ranges from 19.29 to 39.39%. And the sulfur content ranges from 2.48 to 7.45. Based on the results, the ranges of low moisture content, low ash content, high volatile matter, and high carbon content, the coal rank is high volatile bituminous to sub-bituminous type according to ASTM standards. These ranges are indicating the favorable sorption capacity of gas in Patala coal seam. From the scanning electron microscope, we found the internal structure of the coal, and the internal structures were interpreted to understand the generation, migration, and trapping of methane. The samples majorly consist of both face cleats and bud cleats, but having medium interconnectivity. The face cleats are more continuous as compared to the bud cleats. The bud cleats are of shorter extent and are perpendicular to the face cleats. Precisely, the samples consist of majorly S-type and I2 irregular reticular cleat subpatterns. The multiple microscopic pores are identified connected with the microfractures and might act as the main seepage channel. Total organic content is an important parameter to assess the source rock potential for the genesis of hydrocarbons. Higher TOC content generally produce more micropores and mesopores and residual carbonaceous organic matter due to hydrocarbon genesis effect. This increase reduces the stability of coal internal structure and results in the compaction and filling of pores under the action of gravity of the overlying strata. The reduction of the pore results in decreasing surface area and stability of the pore volume even declining. Thank you, sir. The TOC results indicate the coal rank is bituminous type and organic matter is thermally mature. In our samples, the PCP mines have an average TOC of 58.1% and Gamrala coal mines have an average TOC of 70.8% and Gandod coal mines have an average TOC of 79.1%. Masteral analysis helps us to identify the masteral type. From the masteral analysis, masteral composition are found and different masteral types has different effects in gas adsorption capacity, which have brittleness, which affect the macroscopic properties, gas content and permeability. Overall, the organic matter is identified, which is very common and coarse grain in size in the studied sample. Majorly, we found vitrinite and some liptinite in our samples. The average vitrinite reflectance value is between 0.42% to 0.83%, and it indicates sub-bituminous to high rank coal according to ASTM standards. It is interpreted that the vitrinite has the potential to generate microporosity, which also increases the surface area of pores and might result in higher gas sorption capacity in the study area. Patala coal seam was identified by integrating some log responses, the low count of gamma ray log, deflection in spontaneous potential log, enlargement of hole size identified in caliper log, and increase in neutron porosity hydrogen index log helps to recognize the top and base of coal seam in Patala formation. For the coal seam identification, the bulk density log ranges 1.20 to 1.80 gram per cubic centimeter, and sonic log ranges between 100 to 160 microsecond per feet was also utilized. The interpretation indicates the top of coal seam is present at 2,604 meters and its base as at 2,610 meters. The thickness of the coal seam is 6 meters in the Balkasar Oxy 01 well in the subsurface. The geological interpretation is mainly based on the reflectors identification, and it is interpreted that the Balkasar area consists of anticlinal pop-up structure, which is formed by compressional tectonics. The major fault F1 is trending towards northeast, whereas the second fault F2 is trending towards southwest, bounded by anticline. The pop-up structure bounded by fault are favorable for the extraction of methane gas from Patala coal seam in Balkasar oil field. Our results are validated worldwide. Both the Patala formation coal seam and Fort Union formation are of Paleocene age. Both have the coal of sub-bituminous type. The gross calorific value ranges of steady coal seam is approximately same